spend some time on your folio. So just 8F1 today, quantiles. The first part will be a skill we should be familiar with, and then the second part takes that same skill, just adds a little bit of complexity to it. So what we've got here, we've got some normal distribution, we've got some variable x, which is normally distributed, mean of 30, standard deviation 5. Now we are asked to find this number k, such that the probability of the distribution being above k is 0.23. That's what that means. The probability that the distribution is above k is 0.23. So I like to sketch it, right? And so 0.23, if I'm thinking of the whole area under the curve is 1, half would be 0.5, right? So we know that that mean is 30. So 0.23, that's going to be like here somewhere-ish, okay? So I have some value of k, and the probability of being above k is 0.23. Okay, that's what it means. And so we're saying, what's this number k, such that the probability of being above it is 0.23. So the way we do this is very similar to a normal distribution calculation. So in statistics, we're going distribution, normal, inverse normal, okay? And that's going to bring up a number of options for us. So I'll bring them up so I can write them up here. Distribution, normal, inverse normal. So the first one is tail, and tail is really easy to answer. The question is, which way is the arrow pointing? It's pointing to the right. We've got the right area, so we need to set the tail as right. The area is the probability from here, 0.23. That's the area under the curve at this point, right? We have a mean of 5 and a standard deviation of 30. So punch that in. Other way around, standard deviation 5, mean of 30. I've got k equals 32.62, and then we round. All right, so state to 4 figures, round the fourth one. Okay, everyone okay with that?
Yes.
Yeah.
What have I done wrong? Oh, I've got area 0.23. 33.69, thank you. 33.69, which will be 33.7. Much better. There we go. All right, on to B. Here we've got the probability of x being less than or equal to k. Now, in your book it says less than. The reason I've put less than or equal to is to reiterate there's no significant difference between less than or equal to and less than. For continuous variables, they mean the same thing, right? So we have less than k is 0.65. So I'm going to draw the distribution again. And I know, right, that halfway, so if that's, the mean is 30, halfway, that's going to be an area of 50. So it's going to be here, it's going to be this region. All right? So I know that that area is 50% or 0.5, and then this area has to be further 0.15. So I know it's above the mean, all right, and it's talking about area below k. So now our tail is left. Our area is 0.65. Our standard deviation and mean remain the same. So we'll evaluate that. 0.65 to the left. 5 and 30. I've got 31.92. Very good. Area in right that time. Okay, and then on to the last one. When we have a statement like this, it's going to be helpful for me to sketch it for you. We're saying the mean take away some value of k, and the mean plus some value of k give you an area of 0.8. So here's the mean, and then we're going to have the mean take k and the mean plus k, such that this area, so mean take k, mean plus k, this area is 0.8. So it's excluding these sort of edges of the distribution, right? So if we want to perform this one, the tail is going to be central. All right, so we've got tail, we've got left, right, and we've got central. Our area is 0.8. and the standard deviation and mean again remain the same. Okay, now if we do this right, I've got the mean take K is 23.59 and the mean plus K is 36.4. 40. Now, the question said find the value of K. So it wouldn't be enough to just write these, right? There's sort of one more mark required. That's just intuitive, okay? If the mean is 30 and the mean plus K is 36.4, then K is 6.4. Alright, so what it's telling us is this upper boundary is 36.4, but if we want to abstract that value of K, we need to take it a bit further, go the mean is 30, so the value of K is 6.4. Splendid. Alright, all okay with question 1? On to 2. We've got X is normally distributed with a mean of 50 and a standard deviation of 10. Find A. Find this value of A such that between 42 and A, the area is 0.34. So I'm going to sketch this for you. So the mean is 50, right? The standard deviation is 10. And so we're saying between 42 and A. I know A is going to be to the right of 50 because I know between 40 and 50, the area is 0.34. So it doesn't really matter, but just for the sake of precision when I'm sketching it. And we've got this area here is 0.34. Okay, so here's how we're going to work out this value of A. First, we're going to say, well, what is this area here? I'm going to put dots. We're going to calculate this dotted area. And the way we'll calculate that is this is a normal distribution calculation, and we're saying what's the probability of this distribution being less than 42? All right, we want to know what's the probability of the whole distribution being less than 42. So this is an NCD calculation. Our lower boundary will be minus infinity, our upper boundary 42. Standard deviation is 10, mean is 50. All right, so this is the first calculation we're going to need to do. Normal NCD between minus infinity and 22, 42. Standard deviation 10, mean 50. 0.2118. 0.212. So this area here is 0.212. Okay. Now the reason this is useful is because now we can do the inverse random calculation. What we have, this distribution, we've got some value A here, and we know that the area left of A is going to be 0.34 plus 0.212. All right? The whole area to the left, we've given that one, we've calculated that one, and when we add them up, what do we get? 0.552. 552. So then now we're just doing exactly what we did above. It's an inverse normal calculation. All right, inverse normal, the tail is left. The area is 0.552, standard deviation mean, standard deviation. And this is going to give us the value of A. Left 0.552, 51.30. All right, so one way we can check this answer, right? Let's confirm, what does this answer mean? We've determined that the probability of this distribution being between 42 and 51.3 is 0.34. You could perform that as a normal distribution calculation, right? to confirm that it's true. Why was this one a little bit more complex? Because we weren't given this area. We weren't told the probability of being less than A straight away. We had to work that part out using a normal distribution calculation, add them together, and then do the inverse one. So they'll crop up a bit later in the exercise. So that's all we're doing today, 8F.1. Let's give it a crack.